That's really nice. So you will be enjoying holidays, okay?
Yes.
Okay, that's very good. Irina, a very good morning, and we are having Soumya with us. She is a core member of geekzie. Welcome, Soumya.
Hello.
Thank you, sir, for introducing me. Hello, Miss Iarina Dalimon. How are you?
I'm fine. I'm happy that I finished my exams, as I said. How are you?
I'm just fine. So you're a second year student at the university.
Yes.
Okay, okay. So we'll have to wait some minutes because the time was allotted of 12 a.m. So students are going to join at 12. So So tell us something about the actually computers. When I was going through your profile, I have read that you are a computer science and automation student. So that automation part, can you give me something if you are comfortable with that?
Yes, about that. My faculty has two parts: computer science and technology information and automatics. And I am at computer uh, part. Um, a little bit about automation. They um, um, they work with Raspberry Pi, for example, and stuff like this. They are more concerned about the hardware of the computer and stuff like this. They study the hardware part.
Okay, okay. So that assembly language is a when I was doing a research over that, because I'm just a first year student, so I don't know much about that. But still, I was doing some some research over Google. I found that it is it only being used for the low level language programming?
Yes, it is a lower level programming. The computer can translate the assembly language in machine, the language which he understands. It is it is the way he understands things, and it is a way that we can understand what it understands. It is easier to talk with it and to talk with it. And assembly language is useful because it is more faster. It is faster than regular languages, and it is very useful when we want to debug, because from the execution, the part of the program that we run, we can use JDB and see the assembly code of it, and that
Okay.
we understand the program does. And it is
Soumya,
useful.
Uh,
Sorry.
s- yeah, Soumya, it's our first experience. We are hosting this show with an international student, and I'm really glad and really happy that Arena accepted my request to be here with us. And she will be presenting on assembly language. Moreover, it's very much important that she accepted to be a part of geekzie, this initiative. And I also told her that it's very much uh, for it's very much important for both a country point of view also, and also being as a student. She is also computer science person, and we are also dealing with engineering. Irina, Soumya is electronics and telecommunication student. Uh,
Sir, only, so sorry to interrupt, only communication.
yeah, okay, okay, communication, fine.
Yes, sir.
Yeah, but yeah, she will be dealing with computer science stuff also. Okay, and yeah, it's as I just want to be on this platform just to have interaction, that what sort of programming languages at your institutes, Arena, being taught in your curriculum? What about the teaching methodology? And Soumya can also tell from her side that what happens in her college. I will also tell, because I'm the teacher in the institute. So she will tell what's the environment, and I will also help her in between. So how can we have an exchange of ideas, some knowledge, and more important, I just want to just ask something, that being as a student of engineering stream from India and being as a student from Romania, how can we collaborate with each other so we can generate some new ideas, so that if you are working on some project, the students here can help you, or they are working on projects some, so you can help them. So I just want this thing to be happened. This session is basically based on that. What I think.
It sounds nice.
Yeah, actually, I'm very glad that I get an opportunity to be a part of such platform, and all that credit goes to Mr. Nirmal Gaur sir, and because under his guidance, he given that opportunity to us. And I'm really happy that you accepted our invitation, ma'am. That's really
I am very
nice
happy
of
that
you.
you invited me. I mean, when I saw the invitation first, I was like, oh my god, this is happening to me. They are inviting me.
Irina, what is the response? You have posted the poster on your profile, and is there anything, or any of your batchmates asked something about this event? That Irina, are you giving some presentation for a show based on in India point of view in this event? Anyone asked, Irina?
Yeah, they asked me uh, how I become involved in it, how I heard about you, and how all this happened.
Okay, what's your response?
Well, I said that you reach me on LinkedIn, and I said that it is an event where you organize a conference about computer science um, things, whatever whatever people want to talk about.
Okay.
And I told them if they're interested, maybe they can reach to you.
Okay. Yeah, that's a very good thing, and it's very nice initiative if they to also reach us, and we just make an international bonding related to this computer science and all programming and the projects. And so, as I already told that if we are working on some ideas, so we can share our knowledge, and there can be some exchange of information. And we just want to make a very good society, a healthy society, which will help us for development of humanity, and that's the basic goal of Mayat right now. So thanks, Irina, for being a part of this initiative. And I guess it never happened in my institute that the students of my college interacting with the student of any international means or other country student. It never happened. I think
Yeah,
so.
yeah. Actually, that's the very first time.
But I'm happy that I'm the first and I'm here to help you to develop this project because it is an amazing project.
Have you ever visited India?
Oh no, I have never been in India, but I wanted to uh, go to India, but I'm now looking for a job, and after I gain mine, I will come to visit India.
Okay, okay. You're always welcome.
Irina, what do you know about India? If I just ask, what people of Romania thinks about India?
Well, we know that there are many people in India.
Yeah, many people actually.
Yeah, I know that some of you live with parents and grandparents and children. I don't know if this is true,
Yeah,
which is
Yeah, we live
unusual.
in a joint family.
Yeah, which is unusual for us because I live only with my parents and I have no brother or sisters. And usually we have uh, families with two kids or one kid. Sometimes it happen to be more than two, but it is very rare. I know you have spicy food.
yeah, yeah. Indian people are fond of spicy food.
Yeah, and
But actually, living with our grandparents and all our elders is kind of proud culture for us, and because after living with them, we'll get to know many much things and the experiences which they have followed in their life, and so that's quite fruitful and joyful as well. But now also in India, nuclear family concept is started to.
yeah, it is nice to live with all of your members, with all of the family members. What do you know about Romania?
Well,
Yeah, actually, truly speaking, I have seen that in movies.
beautiful place, beautiful people.
And very peaceful as well.
Yeah. Irina, what about education system? The students here, if they want to know how you are having admissions at the institutes, what is the teaching learning environment at Romania?
First of all, there are different faculties. Some of the at the end of the 12th grade, which is the final year of high school,
Okay.
we have a exam named baccalaureate, and with that grade, you can go to some faculties and be a student there if you have like, let's say, the minimum of this. It The people who want to join that faculty uh, goes there and showed their baccalaureate uh, diploma, and after that they are told if they are accepted or not. At other faculties, as it is mine, we have to give another exam. For example, I have a physics and a math exam to be here. Um, to go to another faculty as medicine school, you have to take an exam at biology and chemistry.
Okay.
Um, and this is how we reach our university. For my point of view, it is said that extracurricular activities don't count in the admission process, which is very very sad because I think it is an important part of life and experience. And after that, you asked me about school in general in these times or before COVID.
Okay.
Well, now we are all learning from home. We learn online. We use Teams to join classes. We have courses where the teachers talk about their I don't know talk about what they want to teach us, and they use PowerPoint presentation or things to write on them, like the whiteboard on the teams. And also we have some practical things, like we have another courses, let's tell them like that. And there we have to do things by ourselves. For example, at programming, we have to we have a few problems every time, and we have to solve them. And we are we the teacher gives us grades based on what we worked, and they count on our final grade. Also, we have homeworks, which are a big part of our grade. Usually, they are harder than what we saw before, and we have 2 weeks to solve them. Sometimes we have 4 homeworks or 5 homeworks at a time. We have to do them before the same date, which is very annoying, because we have to know how to manage our time very uh, good, because if we don't do that, we can't finish all of them. We also have exams. We have a period named sessione, and in that period we have exams at um, all of them. And after the exams, we have a final grade, which is a sum of all the things I talk about.
Reena, most of the things here also are same as you have told. Here, students also have to submit their assignments. Right now, we are also having online teaching, and whatever the assignments students have been allotted from the teachers, they have to submit, and on the basis of that, they used to have gradings. In between a semester, we are having two mid-semester exams. That means they are considered sessionals here. That means they used to give two exams in between, and then they are having a final semester exams, and including practicals also. There are some of the subjects which we used to have a practicals. Okay, so a subject is divided into theory and practicals both. So theory exam, it's a written based exam. Right now we are taking it as an objective, or we call it as MCQ exams, online exams, because we are not calling students to our institute right now and write the exam. So they are giving it from a home in the form of MCQ. And for practicals, we used to have a Viva kind of pattern. That means we invite other faculty from the institute, and he used to ask questions to the our institutes that we consider as a practical or Viva exam. And all of these get added at the last, and this is how we give the result to our student.
Nice.
Soumya, you can greet Iarina. I think there are students here, so we can start our session.
Yes, sir. Sure, sir. So, do I start, sir?
Yeah, sure, you can start.
Thank you, sir. A very auspicious good morning to everyone present over here. Today, we all are we all want to collectively welcome Miss Iarina Dalimon, a second-year student of Computer Science and Automations at Bucharest, Romania. So she is going to enhance us about the basic elements of assembly language, in which she's going to cover about the architecture, the registers, the instructions, and the problems which we face while doing that things. So, ma'am.
Hello, everyone. My name is Iarina, and I'm here to know you and to talk with you and to I don't know, just share experience with you, and I hope that you will share something with me. I prepared presentation. Can you see it? Yes, no?
Yeah, it is visible, ma'am.
Okay. So as I said, my name is Iarina. I am a second year student at Faculty of Computer Science and Automotive, Bucharest. It is a 4-year faculty. We also have 3-year faculties, and every year has 2 semesters, and after every semester we have exams. We learn about many things. This is some of the things that I learned so far, and I'm just a second year engineer, like computer programming, data structures, numerical methods, um, logical design, algorithm analysis, something that isn't here. We also talk a little about electronics. We have 3 subjects in 2 years about it. If you have some more questions about my faculty, please tell them. I can see if you are writing. Okay, I guess that maybe on the part, or maybe later we'll have some questions. Um, to say something about it, this faculty also enjoys that also want their student to have extracurricular activities like I don't know, volleyball or volunteer. I'm a fundraiser volunteer in a student association, um, and we are doing projects for our students like hackathons. And today I am here to talk about assembly language, and I hope you will find it an interesting subject because it is very useful when you want to debug something, because using a tool, GDB, you can you can see the assembly code of the project, and that you can find the bugs, or to understand better what the program does when you don't have the written part in C or Java or the language that you know. First of all, when we talk about assembly, we have to say what the is the architecture of the computer, because the assembly language is very different from a category to another. For example, there are 2 categories, CISC and RISC. And it is different because some of them use some commands, like I don't know, for doing a sum, there is a command in one category and another command in the other. And also there are differences between 32 bits and 64 bits architecture. Today I am going to talk about Pentium processors, which is a CISC category and has 32-bit registers. Does anybody know what are registers?
Yeah, it's like allocated space where it resides near the CPU, where you can like store variables, maybe.
Yeah, very good. And there are more types of registers: that data registers, pointer register, index registers, control register, and segment registers. We don't have access to control registers. You can help us to do some commands, but we don't have access of them. They are the processor controls them, and only it. Today I'm going to talk about data registers, and on a 32-bit architectures, there are 4 data registers, for big data registers, called EAX, EBX, E6, and so them are they can be part in 2, and the part from 0 byte to 15 byte is called, for example, for this register is called AX. And if you want to use only the lowest part of the of these registers, you can use AX, but we don't have access to only to this half. If you want to use it, we have to use all the register. Also, the lowest part is has 2 components, L and a hash. This is from 0 to 7 bit, and this one is from 8 to 15. And if we want to use this part, we can use it by calling its name, and this is available. This is true for the rest of the data registers. For example, if we want to use a byte, which is like a char in C language, you use AL. A few instructions increase, which use on register. This command is it means that the value at that register is increased with 1, and the other one, it means that the value of the register is decreased with 1. And here there are some examples. Also, there we can make sum of 2 registers, or I have here a typo. I'm sorry for it. This should be minus, because sub means destination minus source, and the result is stop in it. The result is in destination after this command is made. We also have sum, which for doing it we use add, and compare, which compare D1 with D2. And after that compare, if D1 is smaller than D2, there are a flag that in the register in this control registers that I talked earlier, and that flag is set, and this is how we know if which one of them is bigger or if them are equal. If in my example, when we compare the register AIX with the other one, the result doesn't change. I mean that the 2 registers after this are the same, which is different from add and sub, because after we do these commands, the ECX register change. Another instruction are move and XOR. Move helps us to copy the copy what is in a register to another, and XOR is the equivalent of the logical part is like an and, but it's in the category of and or not and so on. Do you know what XOR does?
Yeah, it's exclusive or.
Yeah. Okay. Here I have some examples. We can also you can use move and add and sub to with we don't have to use two registers every time. You can use a register and a direct value as I have here. It also we can have a direct value when you use add, sub, and other instructions. In assembly, we also have variables, and they are declared in the data section. There is the memory, which have more sections, like stack, heap, data section, text section, and BSS section. And we can declare variables in data section, and we can use variables and to calculate things in our program. And this is what we do when we don't have more registers, because it always happens to need another variable, because there are only 4 registers that we can use to manipulate the variables, and very often they are too little. Another instruction we have this one for bits instructions. This is the left shift. And as my example, we can this way we can multiply on the value at a register, the value that is stuck in a register, with a number. If we have that here 3, for example, that will x will be x multiplied by 2 at 3, which means 8. Also, we have here I'm sorry, I have a typo. This should be like this, and this command is for right shift. And also these two are for unsigned numbers, and for signed numbers we have their equivalent right here. Another type of instructions are the jump one, and there are very many jump instructions. This one just goes to the label to which we want to, and is like go to for from C. Is just to goes to another part of the program. But this one, they go only if another instruction is done, or if a flag is set. The flags are stored in this register, in the control register. It is called, the register is called eFlag, and there are all the flags that can change during our program, and using that flags, these instructions does or this instruction do or do not do the next instruction. For example, this instruction, it is translated like jump if flag 0 is set. For example, if we have if you use this instruction compare, and the two of them are 0 or 1, or the two of them are equal, the 0 flag is set, and sorry, no, the 0 flag, the compare flag is set, and this is how we know if they are equal. And using this instruction jump equal, then we will go to the label, and if it is not equal, then we go to another instruction. It may seem a little complicated, but after I show you an example, I'm sure it will be more clear. Here I use the jump instruction, which just goes to where I want it to go. And here we have an infinite loop, because it will always go back and will never get out of this. In this problem, I have an example when we can use jump instructions to do things. I wanted to compare AX and EAX and EBX, and the result to put in E6X. I compared both of them, and as I said, using this command, which means jump greater. So if they are, if AX is the bigger one, we go to the else, which is the name of the label, and else is here, and we move the value, what is stored in AX in ECX, and after that we go to the next instruction, which is the label and part, and there are a few things in the program after that. It maybe this part may be a small part of another problem. But if the second register is greater, this jump doesn't execute, and you go to the other instruction, which is move ESX EAX. And after that, because we don't want to execute this part, we jump to the end part. It is clear?
Yeah, except what's JG stands for? It's jump when?
This one?
Yeah, what's the condition here? I mean, J and G. So what G stands for here? Is it greater? Oh, yeah.
Greater, yeah.
Yeah.
And we have GL for jump less. Also, we have jump greater or equal, or jump less or equal. There are very, very many instructions, and I will send you a link where you can find all of them at the end of the presentation, and you will see that there are so many jump instruction. Now I have another problem, and I will let you think about it, and maybe um, we can do it together. So, how do you think we should start? Maybe if you see the instruction. First of all, I said that we want to make the sum of the first 10 numbers. I mean, when I said that, I meant the numbers from 1 to 10. And first of all, it is good to have a register when we keep the number 10 to know that we reach when we want to stop, or maybe we can use the compare instruction. We have one register which starts from 0, and we are at every time we increase it, and after that we compare it with 10. We can do this in another program language like C or Java, or what you think is comfortable with you. And after that, we can translate it to assembly. Sounds good?
Yeah, sure, Irina. That's okay.
Yes, sir.
Okay, so here is your part. I want to do this together to create the problem. So how would you start this one? And or we can use pseudocode if you don't want to use a certain language program. I will open Notepad. Let's see. So the sum of first 10 numbers.
First, can we means we have to store value into register, Irina, and then we have to increment.
Yes. So let's choose a register. What register do you want to use to store the value, the sum? Okay, good. Here we'll store the sum. Sometimes we don't have our registers set to 0, so it is a good practice to set them by ourselves, or you can do this by using move instruction, or we can use it by you can do it by using sort instruction. There, it doesn't matter what you use. We do both the same thing here. Okay, so we know where we want to do the instruction, where we want to keep the sum. How can we add the numbers? Someone said that we can use a variable to track the number we are at. Let's use ABX, for
Yeah,
example.
we can have a variable that will continuously store the values.
Yeah. First, and first the value is 1. Yeah, very good. We can use ABX. In assembly, when we want to make a comment, we use this character. Very good. Okay, okay. Okay, so every time we increase the base, now we make the sum. But in assembly, it is called add, the instruction. And now we should compare the ABX with 10 to know if we reach our limit. But we have to compare it with 11 because, well, no, with 10 because we increase it first, and this means that we don't need this. Okay, so now we have to make the loop. We can do it by using jump instruction. What instruction? Well, here are the jump instruction that we need. We have jumper greater than or equal, jump if it is equal, jump if it is less, jump greater. That instructions maybe if I do them. Now, because we compare these two, we know when a base is greater or equal or less than 10, and because of that, when the register is bigger than 10, we have to go out of the loop, and we have to go to do this while a base is less or equal than 10. So we jump every time it is this this is happens. We jump to counter. It is clear. Yes, I mean, not the fact for the question in the text, it depends, because there are some parts that we can use the same assembly language, or we usually use for microcontrollers the RISC assembly language. Here where I am talking about the CISC. It and they are a bit they are different, but it is not such a difference. There are small differences that if you know, there is no problem then. This is a very Apple and Windows have a different logic, or they work on the same plot. This is an interesting question. I think they have the same logic, but I'm not very sure. But I think they are both the same. I will give you my email address here. You can send the question on email, and I will look for the answer to be sure that I will not give you a wrong one. And yeah, I will search it and I will tell you if this is fine with you.
Well, Irina, I just want to say this is programming, assembly language programming we used to do for microprocessor, microcontrollers. And we started programming from machine level. And then, though it was very much complex, that means machine understands zeros and ones only, and it's very much difficult for us to write something in zeros and ones. Then we move ahead. We created a combination of those zeros and ones in the form of mnemonics. What I think there's a term called as mnemonics. And beyond that, we started doing assembly language programming. And yeah, the point is very much clear. You have solved a problem, and you have told about how registers has been declared, how to perform a sum of 10 numbers, and there are certain instructions which we have to use here. We are very close to machine here. That means assembly language. That means I think we are one more level above. But usually what I think is it's very hard to perform assembly language, or we have to write so many instructions in order to perform the coding.
Yeah, in high level languages it is easier because we do on a command and that's it all. And but in assembly there are more commands on for one in C, for example.
Yeah. We started our programming from C language, C++ language, and then we move ahead to Java, then Python, and then we used to have web development languages, HTML, CSS, JavaScript, and all such things. So as you have mentioned that you are having a subject that is computer system and organization or computer architecture. So basically, yes, we are also having that subject in our computer science stream. And basically, students used to learn some part of assembly language there. And I too, when I was also doing my engineering, I have learned some coding in assembly language. And what I know is seems to be very easy in some regards, that if we want to add something, then there is add already present there to add two variables which are present in a register. And if we need to subtract something, that is sub, instruction already present, so we can subtract between the two registers. And as you have already told, that there is a move instruction, that means MOV, to move the contents which are present in one register to another register. And yes, there are jump instructions, jump statements, counter statements, and all such things which are present here. So these are very basics and elementary of the programming language. And after that, we have moved further to C programming language.
Yeah, we also start with C, and after that we learn Java. Um, but in the same time le- we learn about assembly, and
Yeah,
it is nice that we have similarities.
yeah. Host, can you please take questions if any of the student want to ask anything?
Yeah, if anybody wants to ask anything about that, then you feel free to ask it. Ma'am, I have a question. Uh, Ma'am, about the architecture, as in the uh, key points, it was also mentioned that architecture of assembly language, like we have a
Sorry, can you repeat?
am I audible?
Yeah. I didn't heard it. I didn't heard your question.
Okay,
Can you?
let me repeat. Like about the architecture, it was also mentioned in the key points. So, can you tell us something about the architecture of assembly language, like for 8051 and all?
Okay. So as I said, the architecture of assembly language can be different from one type to another. Um, the in the one that I talk about today, there are I will make a drawing. This is, I think it is easier to explain. So we have here the memory, which this memory is a sum of more parts. We have here the stack. Here we have the heap. Um, my right isn't very good. I'm sorry for that. Um, in we can use the stack for more complex programs. When we have other function, we can use it to store the variables. For example, when we have a C function like add like add wait, and we have two numbers that we want to add, you we can put these parameters on the stack and in our assembly language, and after that we can use a command named call, and we can call our function add using that, and using the stack we give the parameters to that function. Also we have the heap part where uh, here are um, the variables that we create using malloc or calloc. these two are also some function that can be used in assembly language using the command call. We just use call malloc. We give the parameters using the stack, and after that you can use it. We can, when you use this command call malloc, we use this instruction. We use the function malloc. We also have a part named data, and here we put our variables. In the data part, the variables that are here, they are global variables, and we have to give them a value. But in the BSS section of the memory, here are the global variables that are initialized by 0, that are initialized with 0 by default. When we and to declare a variable here at the beginning of the program, we just say that here are the variables that are stored in BSS. And also we have the text part, and here is the body of the program.
When it comes to like storing variable in BSS, shouldn't it like store instead of 0, should it store something like that comes from the garbage value? I mean, any random number instead? I wonder because that's assembly, so it shouldn't pick up 0.
Yeah, this happens when we declare something in data part. In the BSS part, the program, the CPU knows that if a variable is declared there, then we want its value to be 0.
All right, thank you so much. Shouldn't it depends on the CPU architecture, or is it like a standard that everybody is like following it?
It's a standard.
All right, okay, correct. Yeah, thank you. You answered my question.
Thank you for it. It is easier for me to answer to your question than think of what should you know or what do you want to know from this. And if you, because we talk about the BSS, I will show you how to declare a variable here. And at the beginning of the program, we just say this, and this way the CPU knows that here are the variables that we want to store in the BSS part. We just name it. Let's call it value, and we have to say what type of value it is. I mean, we want to be 1 byte value, 2 bytes, or 4 bytes. And to do this, we have some I don't know, some default names. We have word for the we have word for 1 byte. Oh, sorry. For 1 byte. Double word for 2 bytes. 2 bytes for 1 byte, 2 bytes for 2 bytes, 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 2 bytes for oh sorry, word for 2 bytes, double word for 4 parts, and byte for 1 byte. And when we want to declare in the BSS section, we use these things. I mean, we say what we want, but in this section, we can also initialize something with more than one. I mean, when we do value the byte, for example, we initialize only one byte. If we want to have like 4 variables of a byte, like an array of chars, we have to use another command, um, which is value rsb, and this will make the program know that we want to have like a buffer, like a array. This means an array of um, of variables with 1 byte, and now we put the numbers. This will be the equivalent of value of 3. It is clear? Do you want to uh, say it in a different mode?
Yeah, ma'am, it's just clear.
Oh, sorry? What you said?
Yeah, it's clear, Iarina. Yeah, yeah. Thank you for
Okay.
yeah. Oh. Well,
Another question.
yeah, any student having doubts, they can ask. Um,
I guess I guess no student have any doubt further. It is something new which they are receiving. So
Well, if you have questions, we can always email me, and I will I will respond you if I know. If I don't know, I will ask other people like my teachers, and I will give you a response.
well, thanks a lot, Iarina. That's a really wonderful thing.
thank you, ma'am.
Thank you too. If you have question about Romania, I can also ask. I can also respond to them. I'm sorry because this wasn't a perfect session. I was very nervous because it's my first time when I do something like this, and I was afraid that you will get bored, or you will think that this isn't interesting, or I will be the worst teacher ever.
No, that was such a great session. We Nobody get bored. I'm damn sure about that. And actually, whatever you have taught to us, that was so much fruitful. Actually,
Yeah,
that was
absolutely.
something new which everyone.
Yeah. So, yeah,
But
please. Yeah, yeah.
learning the new thing is good for us, right? So you are very much good, and you are such a good teacher as well.
Thank you.
Well, thanks, Soumya. Yeah, we thanks a lot to Iarina that it's it's a really a wonderful session. The good thing about this session is we had a very fruitful conversation, exchange, a dialogue, something like that. And as Soumya already said, it's a really we enjoyed a lot this session. And those things which students skip, that means they don't study or something like that, you have covered all those things, because students usually don't know about much about assembly language. They don't bother about what is the architecture behind, what is the means machinery architecture. You told about CISC, that is complex instruction set, and there is one more thing, that is RISC, that means reduced instruction set. Okay, and a part of coding. So all these things usually we don't have too much interaction. So you have covered all these things, and it's really wonderful, and that you have also shared your students to if any doubts they have, they can write to you, they can mail you, and you're gonna reply them. And it's really amazing. And there is one more thing, Irina, I just want to ask, if we can have a combined session. For example, we if we have some topics, and the students from here, my institute, and the students are your institute, so they want to work on this, is there any possibilities?
Well, I will talk to them to see if somebody else is interested to have a session like this from my friends. I
Yeah.
also can talk to my school if you want to be something bigger, and to ask them if they want to interact with you.
Yeah, that's great. If any of the student from our side also want to deliver a session, any of our expertise, if your school or the students want to hear about that, so that will be really nice too.
Yeah, we'll talk with my school and I will give you an answer.
Yeah, sure. And Irina, I just want you to be part of this thing for future endeavors also, to deliver such kind of very fruitful, very knowledgeable sessions. So from my side, from Soumya's side, and from other students also who are present here, they will be definitely wanting you to be part of this culture. So we will be, what I think that it will be easy for us to have a very good knowledge exchange between the two students side.
Yeah, I agree. Thank you for this opportunity and for you being here. Thank you very much
So,
for
may
all of you.
do you want to add something? Do you want to say something to Irina for the last words?
Yeah, I just want to continue whatever you have said, sir. That will be great if there will be a collaboration of your side expertise and from our side, and that's going to be more knowledgeable at a single platform. So we would like, if you are being interested, we would like to invite for our future um, works also. So thank you very much for accepting our invitation and giving such a wonderful session and giving your precious time as well.
Well, any of the student want to say something who are present here? Any student, they can speak. They can open your mic and say. Karthik, you had answered so many things. Do you want to say something?
Yeah, I had a question about this thing, but I think I'm not gonna bore other guys, so I'm just gonna like mail her. You in the starting said something about the GDB, maybe. GDB is it goes with like you debug C programs because to
Oh,
be honest, as the students and people who are like newcomers, we really write very bad code. So yeah, when it comes to like that, we always like ignore the warnings and stuff. Never really know what breakpoints are and stuff. So yeah, I was right, like kind of looking into it. It's a new thing for me, so I'm just gonna go through it before asking something. Make sense?
Okay.
Yeah.
Yeah. We this program we can use it to for debug, as I said, and it opens. When it opens, you can see all the registers in the top part, and in the middle you can see the assembly uh, part of it, and it can helps you to debug to see where it crashes, why there is a problem, to see if you don't have access to the program, then you can use it to see. Also, there is another uh, tool named Gidra.
Yeah,
I,
Girida, yeah, yeah, I know about it. It's the same thing. It just gives you info about the registers and how the program is flowing. So yeah, it's kind of like a good thing if you want more flow over your program and how you're programming. Um, but most of the time, people are like look at the error and like rerun the program and wishing that they have fixed it. And like, yeah, people mostly
yeah,
are into like rerunning and like pressing the keyboard hard enough to like get it compiled. But yeah, so I'm just gonna give it a tour before like asking any question because it's a big thing for me. So yeah, but apart from that, it was a great session. I've learned like about more than lots of things. So yeah, thank you so much.
thank you for your kind words.
Yeah, we have learned a lot of things. So that's a very much we are very much thankful to you from all the geekzie club,
Thank
and
you very
hoping
much.
that you have also find that 1 hour useful for you.
Thank you.
Well, thanks a lot again, Irina, for being with us. And we uh, just wish you ahead for the future, for future year semesters. And definitely, we gonna have more interactions in upcoming sessions ahead. And I just want to thank you again for being with us here. So I hope all others will have a good day. And yeah, okay, Somya.
Yes, sir.
Okay, Irina.
We wish you to have a great future
Yeah,
ahead, and we'll try to, under the guidance of Mr. Nirmal Gaul sir, we'll try to conduct such kind of sessions again, and we hope that you'll accept our invitation just like this time.
yeah,
Yes,
sure.
I will.
Well, thanks, Irina. Thank you, Soumya. Thank you, all other participants who joined our session, and have a good day. Thank you.
Have a nice day, everyone,
You take
and
care of.
thank you for your time.
Thanks, Irina.
Thanks, ma'am. Take care.